Thank you. So I'm Maggie Ding, and I'm honored to be here to present an intellect and data-driven mobile platform for early childhood development using machine learning and data mining. So Easy Nutrition and Education is a mobile app that targets millions of parents and caregivers in rural China and provides a solution to the region's early childhood underdevelopment problem. It provides a recommendation for healthy meals and age-appropriate educational activities, measures children's daily intake of calories and macronutrients, including protein, carbons, and fats, and provides a way to have fun through activities that teach skills and values so as to prevent the underdevelopment of rural children's physical, intellectual, and mental growth. In China, 40% of the 238 million children under the age of 14 lives in rural area. What happened to them matters deeply to China and the rest of the world. According to a Stanford study, 1 in 3 rural Chinese children are cognitively delayed, and over half suffered from the lack of nutrition. Of the 1,800 children in rural counties of Shanxi province, aged 12 to 30 months, who were surveyed, 57% scored below a certain threshold on an international infant mental development scale. Early childhood underdevelopment is dramatically changing the landscape of rural China, where almost 54% of rural children live with some degree of language impairment. Many of these will go on to have difficulties learning at school. So there are two major issues with early childhood development in rural China. First, the study shows that misinformation over childhood nutrition abounds in rural China. Parents don't know what kind of foods to feed their children at what age. Proper food consumption is necessary to boost brain and body growth during pre-adolescence. Without healthy amounts of the right nutrition, the body and brain are unable to function as they should, leading to chronic illness and cognitive impairment. Secondly, research finds rural caregivers, particularly grandparents, do not interact with their children enough. They do not know the benefits of early childhood activities. They don't understand the importance of simulating baby talks, and they don't respond to them and engage with them in communication. They don't understand that the number of words babies are exposed to early on will determine the number of words they will be able to produce before age 2. Also, caregivers don't understand the importance of reading to babies. They don't understand that reading to babies opens up more learning opportunities. The fact that only 10% of rural children have more than 5 books means most rural children have reduced chances of developing an early simulative imagination and may lack essential interpretive and communication skills. Thirdly, caregivers don't play with their babies, and they don't understand that babies learn important life skills through playing games. Parents in China care about child education. The problem is that there are not enough service providers in rural China. However, state and private sponsored early childhood development, which is ECD centers, are becoming more plentiful in urban areas. There are some ECD centers in rural areas, but they're often for children between age of 3 and 6. ECD centers for children before age 3 are rare. And if there are any, they are usually too distant for rural families to take advantage of them. Living in sparse villages where families are busy and maybe dependent on the economy makes widespread usage of ECD centers hard to achieve. Researchers have compared ECD centers to home-based interventions and found that the average impact of center-based interventions was half that of home visiting interventions. Although children benefit the most from ECD centers, rural children and their caregivers are less likely to participate in programs. With this being the situation, it's hard to reach and educate rural parents or caregivers about nutrition and children's activities. While apps and website focuses on early childhood nutrition and education have been developed in China, they mostly targets urban areas because they're more profitable. In rural areas, however, these apps are unheard of. We have developed an app that we believe will provide a solution to this growing problem. Mobile apps and phones are widely used in China. By November 2019, the number of mobile phone subscribers in China has skyrocketed to 1.6 billion. Close to 9 million people in China have access to the internet through a mobile service, and our phone app can be easily downloaded and accessed daily within rural homes. This is our solution. This is an overview. To solve this nutrition deficiency problem, our app provides suggested food menu based on the user's profile, and the parent or caregiver is able to select these menus to use as reference for what their children should eat throughout the week. Then the caregiver is able to record the amount and types of food their children consumes during the day. The system can calculate their daily intake of calories and macronutrients, including protein, carbs, and fats. The users will then receive a rating for the day's meal from bad to good and recommendations to adjust the nutritional and calorie intake based on the data. The app updates these recommended menu as more meals are recorded, and users are able to navigate to any day or meal to see the specific information and rating for each item consumed. To solve the issue of lack of interaction, the app also focuses on cognitive and mental development. The app offers a multitude of activities, such as playing hide and seek, listening to lullabies, and reading stories, which are all designed to engage children's mind. It also contains a built-in calendar, which not only gives the caregivers foresight into days ahead, but also allows them to become more organized in their daily activities. Caregivers can easily navigate the system and find potential nutrition what their children may lack or have too much of, as well as provide their children an alternative way to have fun through hand-picked activities and that teach them skills and values along the way. To solve the early childhood underdevelopment problem, direct intervention through ECD centers, which is costly and less effective, is also limited. Our solution is unique. Not only does it target the underprivileged, it is also scalable. In addition to parents, caregivers, young kids, and teenagers who have access to mobile phones can also use the app to monitor their own nutrition level and participate in age-appropriate activities. Challenges. In order to design a mobile application that provides recommendations for healthy meals and age-appropriate educational activities, measures children's daily intake of calories and macronutrition, and provide a way to have fun through activities and teach skills and value, some challenges have been identified. The first challenge is learning how to develop a nutritional mobile app for multiple platforms. We wanted to make a nutritional app that could be available for both Android and Apple users, because writing the app for both platforms will be time-consuming and require knowledge of at least 2 different languages. We have considered software development that is suitable for both Android and Apple system. And the second one is Chinese rural parents' access to tools. How do China's rural parents get access to a tool that calculates daily calories, proteins, carbohydrates, and fats, as well as if their children is under, over, or of ideal weight and nutrition? And the third challenge is Chinese parents or rural parents' access to nutritional plans and physical activities. So how do they get access to the nutritional plans to improve their children's health? And our solution is first, to develop our mobile application, we decided to use this Flutter software. Flutter is an open source UI software development kit developed by Google. It is open source UI, provides the ability to develop that is developed by both iOS and Android app using a single. Sorry, did I cut off?
It's okay.
Where did I cut off?
Yeah, start from the solution if you don't mind.
Oh, okay. So I'll redo the solution part. So the solution for our first challenge is that to develop our application, we decided to use the Flutter software. Flutter is an open source UI software development kit developed by Google, and it is open source UI, provides the ability to develop applications for Android, iOS, Mac, Windows, and web from a single code base. The programming language that is used to code for the Flutter app is Dart, and Dart is a programming language developed by Google and is used to build servers and desktop applications. So by using Flutter, we solved the first challenge, and we could develop both Android and iOS app using a single code base. For the calories and macronutrition data, we used information from National Health Commission of the People's Republic of China to make the app suitable for all children. In order to calculate daily calorie intake as well as macronutrition and customize the information according to the user's requirement, we group users according to age, gender, and physical measurements such as height and weight. For the total calories and macronutrients of each food, we use data provided by WebMD and save the data in our database. And similarly, we saved recommended food and activities in our database. In order to use the application, a user must enter their child's information, such as name, weight, height, age, and gender. Then the system redirects to the home page. To get the recommended food, the system sends a request to the database, which retrieves the information. On the home page, the user can then see the recommended nutritional plans for breakfast, lunch, and dinner, or create his or her own nutritional plan. If the user decided to create a nutritional plan, they will select the mealtime and add food. After the user selects the food, the screen displays the calories and macronutrients recommendations for activities according to their imported data. And finally, the mobile app also allows users to edit their children's profile after it is created. Experiment. So to evaluate our approach, we collected body weight fluctuation data for 16 participants for 2 weeks. These participants were from 6 to 12 years of age. Some participants suffered from being underweight or overweight, while others have a healthy weight. We conducted 2 different analyses to verify the 2 aspects of our approach. 8 participants that calculated their intake of calories, macronutrients, and observed their weight changes, and 8 participants who used recommendation nutrition plans observe their weight after 2 weeks. In this experiment, we used 8 participants from 6 to 12, 4 children who were overweight, 2 children who were underweight, and 2 children who has a healthy weight. And we utilized the weight data for these participants who, which was recorded by their guardians every day. First, the guardians input the data for their children into the app. Then they include the data that they consumed in the corresponding mealtime every day. After 2 weeks, we collected data and observed the weight for the first and last day of child while using the mobile app. As seen in this figure, some children lost weight while others gained or maintained the same after the 2 weeks. And we observed that one of the underweight children gained weight while other underweight children lost weight. And for the 4 overweight children, we observed 2 maintained the same weight while under 1 lost weight and the other gained weight. For the 2 children with a healthy weight, both gained weight after 2 weeks. And in the second experiment, similar to the previous one, we used 8 participants, all from 6 to 12, 2 overweight children, 3 underweight children, and 3 children with a healthy weight. We utilized the weight data that was recorded by their guardians, and the guardians created their children's profile and followed the recommended nutritional menus for each corresponding mealtime. After 2 weeks, we collected data and noted the weight of the children on the first and last day using the recommended nutrition menus recorded by the app. And similar to the previous experiment, the result of this experiment were that some students lost weight while others gained weight after using recommended nutritional menus. We observed that one children who was underweight gained weight while others lost weight. For overweight children, we observed that both gained weight. For children who has a healthy weight, we observed that all gained weight after 2 weeks. And so for the conclusion, in China, half of the population children live in rural areas. Some of these children suffer from nutrition problems since they don't have access to nutritional tools. And in this paper, we propose a mobile application that runs on iOS and Android platforms and can calculate the daily intakes of calories, proteins, carbs, and fats, as well as recommended nutritional menus. We developed the Easy Nutrition and Education app, which is a personal app for children according to their height, weight, gender, and age. The app can also recommend a nutritional plan and calculate the total calories, protein, carbs, and fats that the children consume each day. For our approach, we performed 2 experiments to observe and analyze the performance for the mobile feature. And through our experiment, we observed that some of the participants lost weight and some gained weight and some remained the same. Even though we observed some of the underweight participant lost weight and some of the overweight participant gained weight, we can claim that calculating daily intake of calories, macronutrients, can still improve children's nutritional health overall. We believe that the recommended nutritional menu will be still an excellent feature for this mobile app after adjusting some of its parameters. And thank you for listening to my presentation.